Hi, this is Mrs. McQuaid, and I am going to discuss graphing inequalities with two variables. So now we have been graphing lines, and now we're going to talk about linear inequalities. By inequalities, in meaning not, that means I want the set of points that aren't necessarily equal, but in this case, greater than, less than. I can have greater than and equal to or less than and equal to. So we're going to start with a greater than. In this case, y is greater than negative 2 times x plus 2. And we're going to go back to the way that we solved our equalities in the last lesson, and we're going to apply it to the inequality. So let's start here with a t-chart like we've done before, and let's pick some values for x. And we like to pick 0. I do, because it's an easy number to work with. I like to pick a negative, and I like to pick a positive. Now, to find the y value, I have to do some computation. It says take the x, multiply it by negative 2, and then add 2. So I'm going to take negative 2x plus 2 in the middle column, this is just a work column to show my work, so that I can give you the y value that goes with that x value, and we can graph them off to the right on my grid. So let me go ahead and put my grid in here so we can really see our graph a little better. I'm going to kind of move it over a little too, maybe. That's not what I wanted. Okay, now we have x equals 0, so I'm going to take negative 2 times x, and in this case that's 0, and add 2. Well, anything times 0 is 0, so when I add the 2, I get 2. So I have a point 0, and the y comes out as a 2. So now I'm going to go over here to my grid here, and I'm going to find when x is 0, which is at the origin, and y is 2. So I'm going to go right up here to 2, and I'm going to plot that point. Okay, so you can see my point A is at the point 0, 2, and you can see it labeled right there. And off to the left, you can see it, the dependent objects. There's my point A, and its coordinates are at 0, 2, just like we found here, 0, 2 off to the left. Okay, let's take x equals negative 1. So if I take negative 2 times a negative 1, and you know I tell you if you're having trouble with your negatives, always double check your answer on the calculator. Negative 2 times negative 1 is a positive 2. Adding 2 more to that, and I get 4. So when I go here to negative 1, I'm going to go back over to my grid. I go back to negative 1, down 4. And I'm going to have to move this around a little bit. So let me kind of slide the grid to the area that I can see. And I'm going to go at negative 1 down here to 4. And I can see when I'm right over it, my coordinates are on it, and there's point B. Now let's get a third point to make sure we haven't made an error. And so I'm going to go, x is 1. Negative 2 times 1 is negative 2. Plus 2 puts me back to 0. So that's going to be an easy one to graph. When x is 1, here we go, when x is 1, y is going to be 0. So I can put that right on the line there. There we go. Uh-oh. Something went wrong. Okay, so my points are not in a line. What did I do wrong? And hopefully you guys have looked at this and said, oh my goodness, Mrs. McQuaid, you made a mistake. Here it is. My point is negative 1, positive 4. My point B is in the wrong place. So I'm going to delete that point B, and I'm going to put it in the right place. So that's how we catch our error. That third point said, oh my goodness, those were not in a line. So negative 1, 4 will be up here. And now my points are in a line. So I have found my boundary line. So I don't want the points where y equals negative 2x plus 2. I want either all the points above the line or below the line. So let's go ahead and make our line through those points. But I don't want the points on this line in my graph. And to show that these points are not part of my solution, I am going to go over here to my line. I'm going to change that line from solid to dashed. And under here, under my line style, I'm going to pick a nice dashed line. There we go. So now it says don't include this line. It's just the boundary line. Just shade all the points where y is greater than negative 2x plus 2. Now, to find that out, we need to find a test point. And I like to use my test point of 0, 0. Unless it's on the line, then you can't use it. So there's 0, 0, and it's down here to the left of the line. And I'm going to do a quick calculation here where I put in 0 for x and 0 for y, and I see if it's true. Is 0 greater than negative 2 times 0 plus 2? So if I take the coordinates from that point and put it into my equation, will I get a true statement? Is 0 greater than negative 2? No. So that is not part of the solution set. It's not on the right side of the tracks, so to speak. It's not on the right side of my dashed line. So the shading must go this way. Okay, oops. Nope, it didn't like that. Let me try that one again. There we go. So the shading goes off to the right with a dashed line. And I have to get rid of that. There we go. And so now you can see my dashed line and all these points. So all these points off to the right are part of my solution set. Okay? But certainly I can't just keep putting in dots. Look at all this. Look at all my dots forming here. These are all parts of the solution set. If I got any of these coordinates, it will make y would be greater than negative 2 plus 2. And I could keep going and going and going and going and going. But certainly I don't want to list all these points. I can't. There's infinite number of points.